Hello, in this super short screencast we're going to talk about two types of reactions. We're going to talk about combination reactions and we're going to talk about decomposition. So combination or synthesis reactions are when two elements combine to form one compound. Now other combinations are possible, and we can see some other things. So for example, when we looked at metal oxides and water making a base, or non-metal oxides and water making an acid, that also could be thought of as a combination or synthesis reaction. A simple kind of combination or synthesis reaction that you all have seen before in chemistry is if you take magnesium metal and combine it with oxygen gas. That's going to make magnesium oxide. Okay, and this is a combination or a synthesis reaction. Now, one of the things that you may notice here, if you paid attention in one of the other podcasts, is the fact that the magnesium is starting at an oxidation number of 0 and going to a +2, so it's being oxidized, while the oxygen is starting at a 0 and going to -2, so it's being reduced. So combination or synthesis reactions also fall into the category of redox. So it's one of those interesting things. Even if you take, for example, sodium metal and combine it with chlorine gas to make sodium chloride, you still would see that there's two elements making one product, but there's also a change in oxidation number as the sodium goes from 0 to +1. It's being oxidized, and the chlorine is going from 0 to -1, so it's being reduced. So again, we see the example of redox there in a combination or a synthesis reaction. Now, decomposition reactions, this is where one thing decomposes to produce two or more products. So the basic example that we always see in chemistry is the decomposition of water to make hydrogen and oxygen. And again, what you'd see here by doing this is you'd see that the hydrogen is going from a +1 oxidation number to 0, while the oxygen is going from a -2 oxidation number to a 0. So again, we've got redox going on. One important thing about this decomposition is it's usually done under electricity, and it's called electrolysis at that point, for the water to be broken apart by electricity. So the decomposition of water to hydrogen and oxygen. We can also take a look at hydrogen peroxide, H2O2, which will decompose to make water and oxygen gas. So we don't get the hydrogen gas out of this one, we get the water and the oxygen gas out of this. Now, some other important decomposition ones to notice here are things, for example, metal carbonates. So if you take like calcium carbonate and you heat this to decompose it, you're going to end up with the metal oxide, but you're also going to get carbon dioxide. And that's pretty important about carbonates. They'll make the carbon dioxide versus something like a hydroxide. So magnesium hydroxide, when heated, will decompose to make the magnesium oxide. But now, instead of the carbon dioxide from the carbonate, we'll actually get water from the hydroxide. So two important examples of what happens when you end up decomposing different compounds. Hope this helps. We'll take a look at a lot more decomposition and composition reactions as we go through, but you can also treat them as redox reactions, which is an important thing to notice as we talk about different types of reactions. Well, we'll talk to you again soon about some solution calculations, so things like molarity and percent.